Hello, welcome back. Today we're going to be working on force practice problems, and it's going to be a review. These are our equations that we're going to be using. These are the ones that we've been using so far. Almost all of these deal with gravity except for the last one, which is just Newton's second law. And then I want to remind you that G could be either 10 meters per second squared or just 9.8 meters per second squared. Well, hey, let's get off to our first practice problem here. Our first practice problem talks about a 25 kilogram pig. Takes off after a rolling corn cob with an acceleration of 5 meters per second squared. Find the force necessary to get the pig up to speed. Well, the first couple here I'm going to do for you, and then we'll try to give you guys a chance to do a few of these on your own. But in this case, if I look at this first one, here it's telling me the mass by saying it's a 25 kilogram pig. And then it says with an acceleration of 5 meters per second squared. So that's obviously the acceleration. Well, that's going to be Newton's second law. And that's F equals ma, where the force is equal to the mass, which is 25 kilograms, and the acceleration is 5. Well, the force then becomes 125 newtons. All right, our next problem here. We got a 15 kilogram rock, which means that's its mass. Kilograms tells me mass. And it's dropped. So right away I'm thinking G, what's G? It's 10 meters per second squared. Or you could use 9.8. Find the weight of the rock. Well, weight is mass times gravity. In that case, the weight is going to be 15 times 10. And that gives us a weight of 150 newtons. Find the distance it fell in 2 seconds. Well, distance equals 1/2 gt squared. So the distance is equal to 1/2 times what's g? It's 10 times the time squared of 2 squared. Well, 2 squared is 4. 4 times 10 is 40. Half of 40 is 20. So it would have fell 20 meters. Find the velocity at 2 seconds. Well, VF equals VI plus GT. What's G? It's 10. So VF equals VI. Well, VI just dropped, so we can assume that to be 0. Plus G, which is what? It's 10 times the time of 2 seconds. So our final velocity is 20 meters per second. Alright, so now I'm going to try to make this a little harder for you so that you guys can do it. It says find the weight of the ball. So I'm going to give you the equation. Alright, first of all, it's a 3 kilogram ball, so that's my mass. Kilograms tells me mass. It's dropped, so I'm thinking G, which is 10. So find the weight of the ball. Let's give you, some of you might be able to do it. If you can, stop it, work these out on your own. I'm going to give you the equations. My weight equation is m times g. The velocity is vi plus gt. And the distance is 1/2 gt squared. And what's g in all these cases? It's 10. So I advise you right now to go ahead and pause it and see if you can work these out. Some of you will be able to do that at this point. Okay, hopefully you paused it. If you didn't know how to do it, then let's go ahead and work these out. My mass in this first one is 3. Gravity is 10. So the weight is 30 newtons. For the velocity, I'm going to do these a little bit out of order, but that's alright. If it's dropped, we can assume that to be 0, the initial speed to be 0. So our final velocity is g, which is 10, times the time of 5 seconds. So the final velocity was 50 meters per second. Find the distance it fell in 5 seconds. Well, the distance is 1/2 times g, which is 10. Most of you guessed that by now, hopefully. And it's 5 squared. Well, 5 squared is 25. 25 times 10 is 250. Half of 250 is 125. And that would be meters. All right, again, now, this right here is a Newton's second law because it gives us a mass of 150 kilograms, and it can produce 300 newtons of force. So that's force. So it's not an A, that's going to be F. I'm going to give you the equation. That's Newton's second law because they want to know the acceleration. So pause it, take a few seconds, see if you can work it out on your own. Okay, if you did pause it, let's see if you got the right answer. If you didn't, we're going to see if we can't calculate it. The force is 300 newtons. The mass is 150. Solve for A. Well, we divide both sides by 150, and A turns out to be 2 meters per second squared. Here's the next one. I advise you again, try pausing it, see if you can work it out on your own. Before you do that, I'm going to give you a little few hints. A mule can produce 3,000 newtons of force, so that's F. And accelerate, that's the word accelerate, so they're giving us A at 2.5 meters per second squared. Find the mass of the mule. Well, we're going to use Newton's second law, F equals ma. The force, you thought I was going to give it to you. Pause it, take a few seconds, see if you can work it out, and then come back and we'll see if you got the right answer. Okay, hopefully you guys tried it, and let's see what you got. The force was 3,000. The mass in this case is what we want to solve, and the acceleration is 2.5. Once you divide both sides by 2.5, the acceleration turns out to be, the mass turns out to be 1,200 kilograms. All right, we've got another one here now. This is our last one of the day. Again, I heavily invite you to try pausing it and working it out. See if you can do it, find the equations on your own. All you got to do is scroll back a little bit and see from the earlier video to find the equations. I'm going to wait a few seconds to give you a chance to pause it, work it out, come back, and we'll go over the answers. All right, find the weight. Well, the weight for this is going to be mass times gravity. Our mass is right here, 300 kilograms. Kilograms tells me weight. Dropped, what does that word drop mean? That means that gravity is acting on it. So we're going to use tan, all right, as our gravity, and that's meters per second squared. So the mass is 300 times 10. So our weight is 3,000 newtons. To find the distance it fell, we're going to use 1/2 gt squared. 1/2 times tan. The time squared is 8 squared, which is 64, times 10 is 640. Half of that is 320 meters. The last one then is to find the velocity at 8 seconds. Well, there's our equation for the velocity. It's dropped, so we can assume the initial velocity to be 0. Velocity final is g, which is tan, times 8. Well, what's 10 times 8? 80 meters per second. All right. Well, hey, hopefully that was very informative for you. I'll catch you guys on the flip side.